chapter number 8, we're going to start talking about ionic compounds. Again, we've talked about the elements and things like that, but what we're going to do is we're going to start looking at those elements and really how they become stable. Now, when we go ahead and begin talking about ionic compounds, really the first thing that we have to do is we have to look at the octet rule. Now, within that word octet, oct, of course, you know means 8, and what we're saying is an atom with 8 valence electrons or a full outer energy level is going to be unreactive or stable. That is what every single element wants to do, is find a way to become stable by having 8 valence electrons. Now, with these 8 valence electrons, atoms can become stable in one of 3 ways. They can do so by gaining, losing, or sharing of electrons. In this chapter, what we'll do is we'll focus on the gaining and losing of electrons. Chapter number 9 will be the one that talks about the sharing of those electrons. As we talked in physical science, atoms will take the shortest route to 8 valence electrons. They'll do that by gaining or losing to get those 8 electrons. An ion is just going to be any atom that has gained or lost electrons to become stable. And what we're saying is the particle carries an overall charge. If you remember the last few chapters, we've said, well, the number of protons and the number of electrons are going to be similar. Now, that's just for the atom. But when it becomes stable, it has to gain electrons or it has to lose electrons to become stable. And when you gain or lose negative particles, then that's going to affect your overall charge. Metals want to lose electrons. Some characteristics of metals is they have few valence electrons. And if they have few valence electrons, they're going to get their 8 valence electrons by taking that shortest route of losing those electrons. When it loses electrons, it's going to form a cation. A cation is just going to be an ion that has a positive overall charge. Nonmetals, they are the ones that have 5 or more valence electrons. So if we have 6 valence electrons, the shortest route is going to be to gain 2 electrons. And if you gain electrons, you're going to form an anion. An anion is just going to be any ion that has a negative overall charge. Now, when we look at the periodic table is set up according to trends. Now, some of those trends, one of them is going to end up being ionic charge. So this first column here, the first column is going to form a +1 charge. All of these have 1 valence electron, and if they have 1 valence electron, for example, let's take lithium, if I lose one, look where I'm at. I'm at helium. Okay, so everything in group number 1 is going to have a +1 charge. Group number 2 again has 2 valence electrons. The shortest route for it is going to be to lose those 2 valence electrons and get a +2 charge. That +2 charge just means that we have 2 more protons than we do electrons. Again, what we're going to do is we're going to go ahead and skip this large middle portion of the periodic table because, again, some of them will usually be +1 or +2. Again, we'll just talk about those later on. So we're going to jump over here. 3 valence electrons, we're going to be +3. The carbon group, it's going to be + or -4 because when you have 4 valence electrons, and again, you have nonmetals up here, you have metals down here, and the thing is, it's going to be just as easy to gain 4 as it is to lose 4. When you jump to this group, you have 5 valence electrons, and when you have 5 valence electrons, it's going to be just as easy, or the easiest route is going to be to gain those 3, and when you gain 3 negative particles, you're going to have a -3 charge. This group is going to be a -2. And this group over here is going to be a -1. So everything right here is going to have this -3 charge. Everything right here is going to have a -2 charge. So again, that trend on the periodic table, if you remember physical science, basically what I said with them is, again, it's up and down the mountain. We're climbing up 1, 2, 3, and then we're at the top, + or -4. The only way to go from a mountain is down, -3, -2, -1. Now, there are 2 types of ions that can form. The first one is going to be a monatomic ion. Just look at that prefix, mana. Mana means mono, and what we're saying is it's an ion or an atom that has gained or lost electrons to become stable. A single atom. What we're doing is we're talking about an atom of sulfur. When I look here, a single atom, it's an atom that has gained 2 electrons. Gaining those 2 electrons, it has a 2- charge. When I look at the second ion, poly means 2 or more. A polyatomic ion is just going to be an ion that is made up of more than 1 atom, but acts as a group while carrying an overall charge. When I look down here, I have 1 sulfur and 4 oxygens. That whole thing is acting as a group, but it has gained 2 electrons to become stable, so this whole thing has a 2- charge. Now, a way that scientists often represent monatomic ions is by using this thing called a box. And basically the box looks like this. This is going to be your template. What we're going to do is we're going to take the mass number. Now, what you can do is you can look at the periodic table, round that atomic mass to the nearest whole number, and that'll give you the most abundant isotope. In the lower left-hand corner, that's going to be your atomic number. Up here is going to be the oxidation number. The oxidation number is just that charge that we talked about when we talked about the trend on the periodic table. Number of atoms, I'll go ahead and explain that one when I actually jump into an example. And then what we'll do is we'll put our symbol in the middle. So what I said to do is let's go ahead and draw the box for calcium and phosphorus. So if we go ahead and look at calcium, I'm going to go ahead and draw my box here. And again, the symbol for calcium is Ca. Now when you look at the periodic table, looking at the periodic table, the one I have on the wall, it says up there that the atomic mass for calcium is 40.078. So if I take 40.078 and I round it to the nearest whole number, that's going to be 40. The atomic number of calcium is 20. Calcium is located in that second column on the periodic table. So in that second column, it's going to be a 2+ charge. Now, I told you I was going to talk about this corner down here, and this corner down here we said was the number of atoms. Okay, if calcium has a 2+ charge, what I'm saying is how many negative ones would it take to cancel that out? So the only thing that's going to cancel out a 2+ is a 2-. Well, if I have 1- and I need to know how many are going to cancel it out, I need to have 2 of them. So I'm just going to go ahead and put a 2 down here. The easiest way to honestly remember this corner down here is take just the number that you find up here and drop it down. Okay, so when you have a 2+, the number's 2, just drop that 2 down. Drawing the box for phosphorus, again the symbol for phosphorus is P. And when I look at the atomic mass for phosphorus, it's 30.9. So 30.9 will round up to 31. The atomic number for phosphorus is 15. Phosphorus. Phosphorus is in the 3- column. So I'm going to put a 3- up here. And if you remember the hint that I told you, I said just take this number here and drop it down. So what we're saying in this one, because this one is a negative charge, what I'm saying is how many positive ones would it take to cancel out a 3-. So +1 give me my 3+, so 3 +1 ions to cancel it out. Now, before we move on, what I would like you doing for tomorrow is I would like you to bring me on a scratch piece of paper with your name on it the box for selenium. When class starts, go ahead and bring that scratch piece of paper up to me with your name on it. Give it to me or drop it off on my desk and go ahead and sit back down. I want this done before the beginning of class. If you have the correct answer for the box for selenium, you'll go ahead and get extra credit. So again, what I'm saying is bring me on a scratch piece of paper, or you can use one of my passes up front, draw me the box for selenium and give it to me before class begins, and that'll be worth extra credit to you. Some properties associated with ionic compounds. Ionic compounds form crystalline solids. Because of that positive and negative pattern, basically we're saying every positive is attracted to a negative. Every negative is attracted to a positive, and that pattern keeps repeating itself over and over, so you get a fixed repeating pattern for ionic compounds. Because of these positives and negatives attracting one another, it holds them tightly together, making them have high melting points. If you have high melting points, you're going to have extremely high boiling points. And the other thing is, they will conduct electricity when the particles are free to move around. And the only time they're going to be free to move around is when they are melted or dissolved in water. And when you melt them, what it does is it separates those ions. And when it separates those ions, because electricity is made up of charges, those charges align with one another, and that's what allows them to move freely. And again, that's the reason, one of the precautions they say is never play with electricity like radios and things like that around water, because again, those particles align, and with those particles aligning, it will conduct electricity. So what I want to do is I want to go ahead and begin talking about chemical formulas. There's going to be some steps to writing ionic chemical formulas. Step number 1 is going to be to write the positive ion first. Step number 2, we're going to go ahead and write the negative ion second. What we're going to do is we're going to circle the number on the monatomic oxidation number. We're going to circle just the number associated with that positive and negative ion charge. Step 4, if you can reduce, for example, if I have a +4 and a -2, we can reduce those down to +2 and -1. So reduce the charges if possible. Cross the numbers that we did in step number 3. Step number 6, if you have a polyatomic ion, go ahead and put it in parentheses. Looking at some examples. The first one is going to be, let's look at aluminum. If we look at aluminum and nitrogen, okay, so we'll write the positive ion first. Aluminum is a +3 charge. Nitrogen is going to be in the -3 column. Now look here, I've got a 3 and a 3. Because I have a 3 and a 3, that's that step where I said they could reduce down. So when they reduce down, it basically goes to nothing. It says to circle the number. Well, there's nothing up there. But again, just going through those steps, going ahead and crossing those numbers and cleaning it up, your final answer for the ionic compound between aluminum and nitrogen is going to be AlN. The second one's going to be gallium and sulfur. So let's go ahead and look at gallium. Gallium, when I look on the periodic table, it too is like aluminum. It is in the +3 column. When I go ahead and go to sulfur, sulfur is in the group with oxygen. It is a -2 charge. A +3 and a -2 or a 3 and a 2, they will not cancel out. Neither one of them are polyatomic. So again, I circle just the number. I cross those numbers and I get Ga, the number that came down was a 2. Notice where the 2 is going. The 2 is going down here as a subscript. It is not up top like those charges. Go ahead and write sulfur. The number that came down on sulfur was a 3. So your formula is Ga2S3. Calcium and bromine. Okay, so again, symbol for calcium, Ca. It is in the second column, so it's a +2. Bromine is in that group with fluorine and chlorine in that last column there. It's a -1. Now, anytime you technically have a 1, we never actually write that number. Circle just those numbers. And again, I'm just going to circle nothing. When I go ahead and I cross them, I go Ca. Now, when I look up there, there was no number, so I don't have to actually put anything down here. Bromine, Br, the number that came down was a 2. So your final answer, CaBr2. Number 4 that's going to deal with a polyatomic is going to be iron 3 and sulfate. Now when I find iron 3, the thing that's going to be unique about it is that Roman numeral kind of gives it away. So we're going to have Fe plus 3. Sulfate's not on the periodic table, so what I'm going to have to do is I'm going to have to go to that chart that I gave you. That chart that I gave you of polyatomic ions is an SO4 2-. Now again, it's SO4. This is a group. So again, I circle, circle, cross, cross, and when I go ahead and clean it up, I get Fe. The number that came down was a 2. Now here's the group again. SO4. SO4 is a group of sulfate ions, and that group always has to stay the same. So notice what happens if I just bring the 3 down. What it looks like is I have 1 sulfur and 43 oxygen atoms. But what that 3 means when it comes down is it means that I have 3 sulfate groups, and one of the rules that I gave you was if a number comes down on a polyatomic, place it in parentheses. So you'll get Fe2, SO4 in parentheses with a 3 on the outside. And kind of like math, when you distribute, that 3 means that I have 3 of these groups in parentheses. And then our very last one is going to be silver carbonate. Looking at silver carbonate, again, silver is located in the middle. And again, because it's in the middle, I didn't give you a pattern for figuring that one out, but it was on the sheet that I passed out to you. So silver has a +1 charge. Carbonate, again, it is a polyatomic, and when I look it up on that sheet, it is going to be a CO3. There's the group right there, CO3. The charge that it carries is a 2- charge. Go ahead and circle, circle, and go ahead and do that crossing that I talked about. And when I go ahead and clean it up, I get Ag2. Go Go ahead and write my group CO3 here. When I go ahead and look back up here, there was no number that was circled, so really no number came down. You can go ahead and leave it like this if you want, but if you feel more comfortable about putting those parentheses, just so you remember that anytime a number comes down, you'll have the parentheses with that number on the outside. But your final answer is Ag2CO3 or Ag2CO3 in parentheses.